All right, so here comes part three of these kind of notes that we're doing here for review. So, yesterday, of course, or the day before, we learned about how to graph logarithms as well. And it looks like many of you decided to choose the parent function technique. So, here we go. When you're looking at this function here, there's my base. So, it's a base of 6. And of course, when I look at this part of my equation here, the 4 is on the inside of a parentheses. And so because it's on the inside of the parentheses, we know it's going to be moving left or right. Here, of course, we're going to think opposite. And as we are thinking opposite, we know that we are going to be going to the left 4 spaces. All right, and here we go. Now, they do want me to state the vertical asymptote and the x-intercept at some point. We'll put that below. So I'm going to the left 4, but remember when you're doing a log, the original asymptote is here along the y-axis at x equals 0. So we know we're going to have a new one at 4 spaces over. So in fact, you know what? Let's get that out of the way. Our vertical asymptote is x equals 4 because we're going, negative 4 because we're going to the left 4 spaces. So we have a brand new vertical asymptote. But let's talk about the parent function. The parent function is y is equal to log base 6 of x. And we said all logs go through the same 2 points. The 2 points, of course, are 1, 0 automatically, and the base, which is 6, and 1. So it's b1 at all times. So if that's the case, I can start by drawing the parent first, just to get an idea of where these points are. So 1, 0, 6, 1, right? And so there's the original parent function without any kind of move yet. But now it says we're going to move everything to the left 4 spaces. So here we go. We're going to move everything to the left 4 spaces. But first of all, that means that right at negative 4, we are going to have our asymptote. And so we have already answered this question. We've answered the vertical asymptote question. We're about to graph. So we're going to go 1, 2, 3, 4 to the left. 1, 2, 3, 4 to the left. And just like that, here comes my graph of this logarithmic function. And it does turn very slowly and then slowly climbs back up. I think I made it go up too high there at the end, but that's the idea. Should be a little flatter there. But there's our graph. Now, they did ask for an x-intercept. Now, I can literally see that my x-intercept is x equals negative 3. So I don't have to do any work for that because I actually see it in my graph, x equals negative 3. And so there's my x-intercept as well. All right, moving on. Now, when I'm looking at this one, once again, I notice that, yes, I'm going to be moving it in this case to the sides, but I'm also going to start moving things down a little bit there. And of course, I see what my base is. So let's talk about the moves. First of all, the minus 3 means I'm going to go to the right 3. Don't forget, that also means I'm going to have a new vertical asymptote because I'm going to the right side. Remember, logs moving to the left or to the right changes my vertical asymptote. And so it's going to be x equals positive 3. So there I have one of the answers that they wanted already for this problem. And of course, this one just says we're going to move everything down 1. Moving an asymptote down, a vertical asymptote down, doesn't do much to the graph, so we can leave it like that. All right, here comes the parent function. The parent function is y equals the log base 6 of x, 3, my mistake, the 3 there. It's looking above. And so there's my base of 3. So now here come my classic 2 points that all logs go through. 1, 0, all parent functions go through that. And then, of course, the b, which is 3, 1. Always the b value there. So 1, 0, 3, 1. So 3, 1. There's the original parent function. Remember, logs keep climbing up very slowly, but they climb up. But now we get to draw it all. We already said the vertical asymptote is x equals 3. Okay, so here's x equals 3. Here's the brand new vertical asymptote. I want to make sure I can still see my points there. And now I'm going to start moving everything over. 3 to the right, 1 down. 1, 2, 3, 1 down. 1, 2, 3, 1 down. And so just like that, we have our two brand new points. And then here comes my curve. Slowly climbing up, but still climbing. All right, well, with that said, we still needed to name the x-intercept. And yes, we got lucky enough that we can definitely see right there. You see, I don't have to do any math for it. The x-intercept is simply, let's write it as a point this time, 6 comma 0. So there's my x-intercept for this one. All right, and finally, our very last graph here. So we do have a third part of the here. There you go, last one. Now this one's a natural log, and that's okay. We can draw these two. Look, it's a base of e. A little strange, I understand, but we can still draw it out. We have x minus 1 in here. We have a plus 3 right here. But remember our breakdown. If as soon as I see x minus 1, I think opposite. So I'm going to the right one. And yes, because this is still a log, don't get thrown off with the whole ln. This is definitely a log, which means I have a brand new vertical asymptote. And because I'm going to the right one, then it's x is equal to 1. Again, I have already answered one of the things that they asked for here. So x equals 1. Now, this means I'm going to move up 3. So that might affect my x-intercept. We'll see right now. So here's the parent. Y is equal to the natural log of x, right? There's a base e. We don't have to write it, but there's my natural log of x. So x and y. What do all logs go through? 1, 0. And then, yes, the b. Now, the b is e. E1. Another way of thinking about that is 2.7 comma 1, right? E1 is just the same as 2.7. So we're dealing with the decimal. That's all right. 1, 0, 2.7, and then up 1. All right, so here's the parent function. Not my answer yet. But here comes the new asymptote. Remember we said there's a brand new asymptote here. The asymptote is x equals 1. So we'll draw that out. Now we're going to move every point over just the way they said. And we're going to move it over a distance, according to them, of 1 to the right, 3 up. 1 to the right, 1, 2, 3 spaces up. Now I know this one's weird, but look, you were halfway. We're at 2.7, then 1 to the right, and 3 up. So you see it's still kind of in the same location there in between. So we have this point, and we have this one. And there's my graph of our natural log there. Now we do have a little bit of an issue for the first time. I can't tell what that x-intercept is. I mean, it's just over a 1. So only way to find it, and so we hadn't had to do this yet. Remember, when you're finding an x-intercept, all you have to do is make your y equal to 0. So 0 is equal to the natural log of x minus 1 plus 3. All right, I need to get this by itself. Yes, there's an invisible e there. So I'm going to subtract the 3. See if we have enough space here. Negative 3 is equal to the natural log of e, x minus 1. All right, I got to go exponential with it. So here comes that circle method that we've been talking about so much. And so I end up with e to the negative 3 is equal to x minus 1. And yeah, I knew we were going to run out of space here on this paper. That's okay. Look, I'm going to move it this way. Yeah, in fact, let me move it now. I don't want to do any math moves yet. Negative 3 equal to x minus 1. All right, so I'm going to add a 1 to both sides. And this is honestly a calculator problem now. It's tough for us to work with e. And so we'll have to approximate it, but that's fine. Remember, this is an actual number. It's not a letter. It's an actual number. So that's why I have to bring in my calculator for this. All right, so it says e, if I can find it, there it is, e to the negative 3, and then it says plus 1. Let's see what we get. Yeah, remember we said it was just over the number 1, and yeah, this is 1.05. So 1.05, that's the best that I can do for my x-intercept. All right, so just like that, remember, sometimes you have to do a little bit of work to get that x-intercept. So give the numbers 24, 25, 26 a try, and then obviously the homework begins right after this page. All right, everybody, have a wonderful day.